Hi everybody. In this video we are going to discuss about delete a node in the beginning. But before I start, I want to tell a small case which I missed in insert position. So in the previous video we were discussing about the insert at a given position operation. I missed this case. That is when the list is empty and if you are trying to insert at position 2 for okay, let us try for 1. This is the case when the list is empty, that is you are creating a variable for the structure and then you are calling the create list function which will initialize head equal to null, and then directly I am calling this insert at a given position, giving the address and so on. So when we look at the insert position, what happens is if position is 1, we are directly calling insert beginning. In insert beginning we are handling all the cases, like if it is empty also it will be dealt. So there is no problem at all. So let us run it. What you will say is list is getting printed 10. Okay, 10 is the value which we have just inserted, that is getting printed, no problem. But when I was trying this option, actually in a empty list you are trying to insert element 10 at position 2. When I try to do this, what will happen is, let me run and show you and then I will tell why it happens. Okay. You see, you get segmentation fault. One more thing I want you to notice is I am outside. You see, I have printed 2 messages before loop and I am outside. Let us go and see in the code. When you go to the code, insert position, yes, it's here. So what do we do here? We get the list, we get the position and the data, and you are checking if the position is 1, you are calling insert beginning. That's fine. Otherwise, what we are doing is we are making temp is equal to head and I am printing before loop. Actually null value will be printed as null, that's what you are seeing here. Since the list is empty, head is null. Okay, and then we are running a loop. In the loop, what do we say? Counter less than position minus 1. What is the value of counter now? Counter is 1. We have initialized to 1. Position is 2. 2 minus 1 is 1. So this loop will not be entered at all. 1 is not less than 1. Okay, so it will go outside, print this I am outside, that's what you are seeing here, and after this it will create a node using the function create node. That's fine, and it is checking whether it is successfully done or not. And then you are in this particular line number 84, what you are trying to do is you are trying to store the address. Okay, that is the value in the next part of the temp variable in the next part of the new node. But actually temp is null. You are trying to derefer a null pointer. So at this point you will get segmentation fault, right? This is the only case which I was trying and it got failed. So I was thinking about making a change, like if position is 1, there is no problem. One more thing we can add is if the list is empty, right? If is empty of the list, right? Actually we have to pass it by value, so only I have put a star, just recall that point, and you can put a and position greater than 1. If it is 1, no problem, but if it is greater than 1, then we are going to return, right? We are going to return 0. Okay, that is insertion cannot be made. If the list is empty, if you are giving the position as 1, that's fine, insertion can happen. But if the list is empty, you are trying to give a value more than 1, it's not possible to insert. In that case, we have to return 0. That's what we are doing here. Okay, yes. So let us compile the code and run it. Now you will see that it is getting printed. Yeah, there is no segmentation fault, but yeah, because the list is empty. Yeah, the list is empty, so you are not getting anything printed, right? This is good. So segmentation fault is not there. That's what we expected. So one change that we have to make in the algorithm is in the step 2, step 1 is if position is 1, then you will call insert beginning. Write the step 2 as if list is empty and position greater than 1, then return false. That's what we made. This change we have to make in insert position. That's what I was thinking about. Next, what we are going to do is we are going to discuss about the delete beginning function. So what is delete beginning function is, if you have got a linked list and you want to remove the element at position 1, then it is going to be delete beginning, right? Okay, so when you look at the case, actually for insertion every time we have to check whether it's full. Similarly for delete operations you have to check whether the list is empty, right? If the list is empty, then we have to communicate false, right? You have to tell the caller, okay, the place where this function is called, we have to communicate that this is a failure, but we are going to return the value. For example, in this linked list, if you are going to do delete beginning, I want to return 10 because 10 is the value which is getting deleted. How I am going to define this delete beginning operation is, it is going to take the list as an input and it is going to return the element which was in that particular position. Okay, in the beginning means actually if I run for this particular linked list, I should return 10 and I should also remove this node from the linked list. So in that case head should be here. That's what these changes I want to make, right? So the first thing that we will check for any delete operation is check whether the list is empty. If the list is empty, we have to communicate failure, but we cannot return as we were doing in the insert operation. So there is no other way to communicate. In C or C++, you can return only one value, right? So what we are going to do is, we are going to have global error flag and we are going to set it, reset and so on. This is what we were doing for array implementation also, the same thing. So declare a global error flag for indicating the deletion error, and then you have to initialize that to false because it's an error flag. Initially there is no error, and each time you enter the function also you will tell us, you will make it false, and then if actually error happens, then we have to make it as true. And in the place where we call these functions, after the function call we have to check whether the error flag is being set. If the error flag is set, then you have to print that no, deletion could not be done successfully. Otherwise you have to print that deletion has happened successfully, right? This is the idea that we will see in detail when we are going to implement, right? So let us see the algorithm. As I told you, the input is going to be a list, and you are checking here if the list is empty, then you are going to return -1. I will return because I have to return something, so I am returning, and also you have to set the error flag. Both the things should happen, and otherwise you will come to step 2. In step 2, what you are doing is, you are declaring a temporary pointer temp and you are making it to point to the first node. That's what we were making here, right? First you will create a temporary pointer and you will be making it to point to the first node, and then I will declare another one variable, that is temp int, right? What I will do is, in temp int I will store 10, okay, whatever value was here I will store in temp int and make head to store the next part of head, right? Now your head should move next, right? So what you are doing, head is equal to head next, that's what you have to tell. That's what is said by the algorithm. Make head to store next part of the head and you have to return temp int, right? This is the algorithm, okay? Yes, I think that's fine. This much is only required for delete beginning, and it will cover all cases. Already we have discussed about emptiness, and for when there is only one node also, as per the algorithm, head is equal to head next, so head will become null. That's the condition for a list being empty. Okay, right. So let us go to the implementation and start doing it. First I will declare a global error flag. In C you do not have boolean things, right? Okay, I'll start a fresh file. Yeah. In C you do not have a bool data type, so I am going to use int itself. Int, I can tell delete, int delete error flag, okay. This flag I will use, and I will tell initially this is equal to 0, right? This flag is not set, and I am going to write the delete beginning function. What is the return type is? The elements in this list are going to be integers, so the return type is also int, and I am going to pass the list by reference. Only the list will come as the argument, okay, and I am going to tell delete error flag is equal to 0, okay. You see that it is not being set, it is false, and then you will be checking if the list is empty, right? If is empty of this, Then what you will be doing, you will be telling two things you have to do. You have to set the error flag is equal to 1, and then you have to also return -1. This is what you have to do, right? Otherwise what we will be doing as per the algorithm, what is the algorithm ask you to do? You have to have a temporary pointer, okay, node star temp, okay, and also I want a tempint function, it's a tempint variable, okay. So now I will be telling temp is equal to head of the list, okay. You have to make temp to point to the first node, and you make temp int, okay, temp int is equal to L data, you store the data, and then you have to tell head equal to head next, you move the head, right. You may think, why do I want a temp, right? Why do I want a temp? I can simply leave like this, isn't it? Of course the code will run. I will run as such and show you that the code is running, and then we will discuss why I asked you to store the head in the temp node, right, temp variable. Okay, I had a error actually. This is head is undeclared. Why? Because I used as head data, right, and head is not known. Actually we have to use as L head data, that was the mistake, and in the next line also we have to tell L head is equal to L head next, right. Yes, and I have made the name to be also uniformity. For uniformity I have made it as delete beginning, and I have returned the main. So in the main what I have done, I am calling the delete beginning function and storing the return value in T, and I am checking the deletion flag, okay, delete error flag, and if it is true, right, then I am printing deletion failed. Otherwise I am telling what is the value deleted, and also I print the list. So in two places I print the list. Let us see what happens, okay. So let us compile and execute, okay. So what do we get here is actually we are deleting in the beginning. I am getting a garbage value, and but it is deleted, but I am getting a garbage value. Let me see, I didn't return actually, that is the problem. See here, I haven't put the return statement, I have to put the return statement, return temp int. This one I have to do, right. So let me compile and run the code again. Yeah, what do we see here? Let us see, okay. So first we are inserting 1, 2 is in front of us, so 2, 1, 5 should have come, and also 10 will be inserted at the position 2. So 2, 10, 1, 5 you will get, and what you are doing here is you are calling delete beginning. So T will contain the first element 2, that is what you are getting here, value deleted is 2, and when you see the rest of the list 10, 1, 5, everything is fine only. Then why should we have a temp? Why? Because we should deallocate the memory. We got this memory, this piece of memory which was allocated for that particular node. We used malloc and got it. We have to give it back using free. So only I have stored it. Otherwise what will happen is it will become a garbage, and it will be collected only during the garbage collection. For small programs like this, when we are running in our system, you cannot find the difference. But if it is a real-time application which is going to run for hours together or days together, then there will be a surely impact on holding the memory. We should not do like that. It's a good practice that whenever you use dynamic memory allocation, you properly deallocate it. That's what we have done. Okay, so the code will be shared in the GitHub, and you can have a look at it. Thank you.